Dear students, we are learning results under vector differentiation. Already we have completed results 1 to 4. Now here we have result 5. It is given that if r vector is equal to xi vector plus yj vector plus zk vector, then nebula dot r vector is equal to 3 and nebula cross r vector is equal to 0 vector. That is, the divergence of r vector will be equal to 3 and the curl of r vector will be equal to 0 vector. So we have to prove this. So let us take this as the first result under result 5 and this as the second result under result 5. So we shall first prove that nebula dot r vector is equals 3. Now in order to prove this, we shall consider nebula dot r vector. We know that the operator nebula is given by dou x of, that is, I vector multiplied with dou by dou x plus j vector multiplied with dou by dou y plus k vector dou by dou z. So this is nebula operator. So dot product with r vector. So what is r vector? It is given here that r vector is xi vector plus yj vector plus zk vector. So usually r vector is taken in this manner, which is the position vector. So it is xi vector plus yj vector plus zk vector. Now we have to take the dot product of these two. So we know that dot product we have to take component wise. That is I with I, j with j and z with z. Because I with j, I with k becomes 0. Also j with I and k becomes 0. Similarly k with I and j becomes 0. So component wise we have to take, that is I with I is 1. So we have dou by dou x over here. So here we have x. So it will be dou x, differentiation of x with respect to x, plus the second is j with j. So differentiation of y with respect to y, plus differentiation of z with respect to z. So because here we have z. So when you see, we see that this is equals, this is 1 plus this is also 1 and this is also 1 and therefore it is equal to 3. Therefore we have proved that nebula dot r vector is equals 3. So we are done with the first proof. Next we have to prove that nebula cross r vector is equal to 0 vector. So in order to prove that, we shall write what is nebula cross r vector. We know that the cross product is given by determinant of I vector, j vector, k vector. And here we have dou by dou x, dou by dou y and dou by dou z. And here we will be having the x component, that is for x, ith component of r vector. Here jth component of r vector and here kth component of r vector. So what is the ith component of r vector? We know that it is x, jth component is y and kth component is z. So we shall write that here. So we will be having x, y and z. Now we have to find the value of this determinant of this matrix. That is equals, determinant is given by I vector multiplied with dou by dou y of z. But we know that z is will be treated as constant when partially differentiated with respect to the variable y. So what will be this? Dou z by dou y will become 0 minus dou z by dou by dou z of y. Again, differentiation of y partially with respect to z. So y will become constant and therefore on differentiation it becomes 0. In a similar manner, for determinant we have to have negative of j vector multiplied with. So block this column and block this row. Dou by dou x of z. Again, differentiation of z with respect to x partially will give us 0 minus differentiation of x partially with respect to z. Again it gives us a constant, plus k vector multiplied with, now here block this column, block this row. So dou by dou by dou x of y. So y is partially differentiated with respect to the variable x. So it will be 0. Minus dou by dou y of x. Again this also becomes 0. So therefore we get this to be equal to 0 I vector minus 0 j vector plus 0 k vector, which gives us 0 vector. Therefore we have proved that nibla cross r vector, that is the curl of r vector, is equals 0. These two concepts are very significant in proof, and they can be applied in further results that we will be deriving. So this is result 5. So I hope you would have understood how to prove nebula dot r vector is equal 0 and nebula cross r vector is equal to 0 vector. Kindly follow the next video lecture to understand result 6. And all the results are separately categorized in a playlist called vector identities under vector differentiation for your convenience. Thank you.